Alright, so this is going to be 3.1. So we are going to look at vertex form of a quadratic equation. And I'm just going to show you what that form is and work a problem here. And then in the next video, I'm going to make sure you understand how to find everything that they're actually asking for in each problem. Alright, so this is number 10. I'm going to work number 10. So we've got our function equals x squared plus 4x minus 1, and you recognize this hopefully as a quadratic equation because my highest degree, the biggest exponent, is 2. Alright, now what I'm talking about putting this in vertex form, your book calls standard form. But I call it vertex form because you can look at the equation and see what the vertex is. Alright, so that's what we're talking about. We're looking at some number times x minus h squared. So we've got something squared, so you're still going to recognize this as a quadratic, plus k. Alright, so my vertex is going to be hk. And notice that this is x minus h, and h is standing by itself. So really what's going to happen here is my sign's going to change. And then I've got plus k. So that sign, that coordinate, that sign's not going to change. And then we've got this number out front. And that number out front, if it's positive, then our parabola opens up, and if A is negative, a parabola opens down. Alright, so let's just look at that, what we know. So if I had some function, let's just do the parent graph. So we already know how to do parent graphs because we've done transformations. But if I'm looking at f of x equals x squared, well, I know that that is a parabola that opens up. Alright, so now what we're looking at is the vertex form of all this. So remember I told you that A determines whether I'm opening up or down. Well, A in this particular case is understood to be 1, so that would be positive, so this parabola is opening up. Now, it's also telling us what our vertex is. The vertex is where the parabola changes direction. So if I'm reading this from left to right, I'm going down, and then I change direction, and I'm going up. So my vertex is where I change direction. Now, if I take this same function and make it negative, remember that that negative, all that does is reflect it over the x-axis. So now I've got a parabola that opens down. So if I'm looking at my vertex, I'm reading left to right, I'm going up, 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 and then I'm going down, 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 down. So I'm changing direction right there. So there's my vertex. Alright. The other thing that vertex form tells me is whether I have a maximum or a minimum. Now, if we're looking at these two parent graphs, I'm looking at this and I'm going, well, there's not a maximum value. This graph goes on and on in both directions, in the positive direction, but it does have a minimum because it opens up, so I've got the lowest point of that graph is going to be there. On the flip side of that, if I flip that parabola, obviously it doesn't have a minimum because it goes on and on in both directions, but it does have a maximum value. So really A is going to help us to determine whether the parabola opens up or down. It's also going to tell us whether it's got a maximum or a minimum. Alright. K is actually what that maximum or minimum is. Alright, so these are the things that we're going to be looking at in 3.1. Vertex form. So I'm going to take this function, number 10, f of x equals x squared plus 4x minus 1, and I'm going to put it in this form right here. So the first thing I'm going to do is take my terms with x in them, and I'm going to separate it from that constant. Now, if I want to get a perfect square here, I need to do what's called completing the square. And I kind of want to do this off to the side, so I want you to understand what's going on here. So I'm going to go back down here. If I have x plus 3, I'm going to use 3 instead of 2 because 2 gives me 4 whether you add it or multiply it. I don't want y'all to be confused. So if I did x plus 3 times x plus 3, I know that that is x plus 3 squared. Alright, this is a perfect square because it's something squared. If I multiply this out, I get x squared plus 6x plus 9. This is called a perfect square trinomial. Alright, that just means that this factors into a perfect square. What I'm trying to get you to see is the relationship between this number and this number. Alright, if I take half of this number, half of 6, and I square it, so half of 6 is 3, and then I square it, that equals 9. Alright, that's what I'm trying to do up here. If I take half of 4 and square it, I get 4. So I get half of 4, which is 2, and square it. That's what I'm going to add to make this thing a perfect square trinomial. Now, you have to understand that what I've just done here is change this problem because I just came along and said, alright, I'm going to add 4 here. Well, if I add 4 here, I have to undo that. So I haven't changed the problem. Well, the opposite of 4 is negative 4. So as long as I do the opposite, really if I said what's 4 minus 4, you know that's 0. So really if I do the opposite here, I haven't changed this problem at all because in essence all I've done is add 0. Alright, then all we have to do is write this in vertex form. So here's my perfect square trinomial. I need to write that as x plus 2 squared because I just factor it into a perfect square, and then I've got minus 5. So now I've taken my original equation and I've written it in vertex form. Now once it's in vertex form, you should be able to just look at it and see what the vertex is. So if I'm looking at that, remember h changes sign, so my h coordinate is going to be negative 2. My k value does not change sign, so that's going to stay minus 5. So there's my vertex. Alright, I know that my a value here is understood to be 1. That means this is going to open up. Alright, and if it opens up, just visualize it opening up. Is it going to have a maximum or a minimum? Well, if it opens up, that means it's got a minimum. And my minimum is k. And k in this case is negative 5. Okay?